First video from chapter 6 is going to be on friction and the different types of friction, and it'll cover chapters 6.2, 6.3, and 6.4 in the textbook. Okay, so friction. First off, what exactly is friction? So friction occurs when you have two surfaces that rub up against each other. Now, and it's due to contact between those surfaces at a microscopic level. So, and in general, that means the smoother things are, you increase the contact area, then there's more interactions at the microscopic level, so the friction is going to increase. So one way to think about it, so if you imagine each of these, so your objects are made up of little molecules that are all bonded together, and you can think of those bonds as little springs. So now if you imagine you have two surfaces and you press them together, and you press them together harder and harder and harder, so those springs start to compress, and the amount of contact actually increases and friction goes up. So we can divide friction into three different categories. So first off is kinetic friction. So kinetic friction happens when you have two surfaces and they're sliding across each other. As opposed to static friction, static typically means at rest. So if you have static friction, you have your two surfaces, but they're not moving with respect to each other. So, and then finally, rolling friction. So if you have an object that's rolling, well, in general, again, imagine, you've got these surfaces are made of these molecules connected by little springs. So if things are a little bit squishy, if you have an object, a tire or a cylinder of some sort that's rolling, things are going to squish down a little bit, and that's actually going to create some opposition to the motion, some friction. So that's what we call rolling friction. So these friction and drag forces are resistive forces. So that's going to be important because we're going to have some equations that tell us what the magnitudes of these things are. And the fact that they're resistive tells us about the direction. So namely, they oppose motion. So if you're moving to the left, friction is going to be to the right, and vice versa. Okay, so first off, kinetic friction. So remember, kinetic friction is when you have two surfaces that are sliding across each other. Now the magnitude of kinetic friction, so I'm going to use F sub k here to stand for kinetic friction. So, and that's going to be this constant mu sub k times the normal force, F sub n. So mu sub k is known as the coefficient of kinetic friction. So it depends on the surfaces. So if you have very little friction, so say like ice on ice, right, it just slides and there's hardly any friction, mu is going to be a small number, like 0.1, 0.01, something like that. On the other hand, if you have surfaces where there's a lot of friction, so let's say sandpaper on sandpaper, so friction, there's a lot of friction, which means mu k is going to be big, and usually like 1 is a big number here. So another interesting thing to notice, so it only depends on the surfaces you have, so all of that is encoded in this mu k parameter, and the normal force. So the speed that you're sliding at actually doesn't matter. So if I slide twice as fast, I'm actually going to get exactly the same amount of kinetic friction. The other thing, so remember this equation only tells you the magnitude, right? And it kind of has to be that way since we know that the normal force, well, imagine you're on a flat surface, the normal force is going to be straight up, perpendicular to the surface, and kinetic friction is going to be opposite. So they're not even in the same direction, right? One's horizontal and one's vertical. So, but remember the fact that these are resistive forces tells us what the direction has to be. So if you're sliding to the right, friction's to the left, and you're sliding to the left, friction's to the right, and so on. Okay, so now static friction when you have your two forces, or your two surfaces I should say, and they're not moving with respect to each other, right? So my hands are stuck together, I'm actually trying to move my hands a little bit, but they don't move, and they don't move because of static friction. So they're not sliding across each other, they're at rest with respect to each other. So the equation for static friction looks very similar. So I'm going to use F sub s for static friction, and that's this coefficient mu sub s times the normal force. So mu sub s is similar to mu sub k, it's the coefficient of static friction now, and again it depends on the surfaces. So, and again, just like similar to kinetic friction, the direction of static friction always opposes motion, or opposes attempted motion is probably the better way to say it, because after all, your surfaces are at rest with respect to each other, so you don't actually have anything that's moving. But again, imagine you've got a big box that's just sitting there, right? And if you push it to the, if you try to move it to the right, friction is going to be to the left. And you try to move it to the left, friction is going to be to the right. So it opposes the attempted motion. Now, the other tricky thing to remember about static friction is this is the maximum possible static frictional force. So it can always be smaller. So if you push on the box with less force, static friction is going to be less. If you imagine, so you take a box, right, and set it on some surface with friction. You start to push, and you push with a very, very light force. Well, it's not, so let's say it doesn't move. And static friction is actually just going to be opposite to the force, equal and opposite to the force you're applying if nothing's moving. So now you push a little bit harder and a little bit harder and a little bit harder and a little bit harder. So your applied force is getting larger and larger. Static friction has to get larger and larger if the box is going to stay in place. But eventually you're going to reach some maximum possible static friction and the box starts to move. And then at that point you're sliding and you don't have static friction anymore. You have kinetic friction. Okay, so the final one is rolling friction. So here if you have a wheel or a cylinder of some sort, so since the surfaces are going to deform a little bit, again imagine these little molecules connected by springs that are going to compress a bit. So this rolling motion is going to experience friction. So, and we can parameterize this very similar to the other types of friction. So F sub r is the rolling friction, and again it's a mu sub r now, a constant, times the normal force, where mu sub r is the coefficient of rolling friction. And again, it depends on the surfaces. And the other thing to remember, so rolling friction is actually typically weaker than both static and kinetic friction. Okay, so last slide here. So typically, right, so we parameterized friction with these equations. So we need to know what these coefficients of friction are. So these are not something you can go off and calculate. These are something you go out and measure. So you get a couple of surfaces and you measure the force of friction and you can measure what these various coefficients are. So this is table 6.1 from your textbook that lists a whole bunch of these. And so you see that yes, for various different surfaces and things, then they have all sorts of different values for these coefficients of friction. So for example, Teflon on Teflon, there's not much friction there at all, and the coefficients are very small. So 0.04 for static friction, 0.04 for kinetic friction. Whereas something like rubber on dry concrete, so there's a lot of friction. Well, and that's what your tires, right? Tires on a road, so they're kind of supposed to have a lot of friction. So static friction has a coefficient 1.0, kinetic friction is 0.8. Now, the other thing to note here is that generally the maximum possible static friction is larger than kinetic friction. So this means that the mu sub s is almost always bigger than mu sub k. And then finally mu sub r, the coefficient of rolling friction, is even smaller.